Hi, this project is related to thermal behavior of hydraulic system in which we have used the Servo Hydraulic Actuator and Digital Electro-Hydraulics Hydrostatic Actuator. So basically in in this complete structure we have just used the development of flight control system to provide its the servo hydraulic actuators, like we call it SHA SHA, and the other one is we have just need to control the reliable exhibit internal leakage and significant heat generation. And I have just designed it's the complete servo hydraulic actuators as well as the digital electro hydrostatic actuator. We call it DEHA. Okay. So in the multi-chamber cylinder capable of 43 discrete velocity levels, we need to achieve the efficiency up to 60% temperature estimation was performed using Carvalho's 2023. So in our structure, we are just going to improve the efficiency from 60% to above and through MATLAB simulate model, and we have just exceeded the temperature 40 degrees Celsius and the 20 degree Celsius to ambient level, evidencing reducing the heat and improved efficiency. Okay, so I have just written the complete abstract with the introduction, like how we can develop this. We just developed this system, and this is the complete introduction. Contains its the hydraulic system contains. These are the references I have added. How 60% improved efficiency with the traditional efficiency, and the research also added here. The main objectives are defined here, like how we can use a steady state response of aircraft for a flight control system with the SHA, and how we can just perform the digital hydraulics in the special of digital electro-hydrostatic actuator. So these are the objectives written here, and we need to achieve. And the literature review I have added in this section. And this is a complete simplified of uh, illustration of forces on an aircraft model, like which forces are developed. Basically, multiple forces are acted on this model through speed, through torque, through length, through uh, like direction of the aircraft model. So next part is basically I have just added the complete high lift devices, like when the plane lift one side and how it acts uh, in different um, forces, and what forces are placed on this basically aircraft plane. Okay, so flight control services I have added here, which is basically we use the rudder, elevator, aileron, uh, aileron. So these are the primary control services for the typical aircraft model. I have added the complete aircraft control actuator system, and this is basically the mechanical hydraulic actuator with hydraulic valve powered by the centralized hydraulic unit. In this we have just this is a control surface, this is a hydraulic valve surfaces, and the input signal is here, like the oil input here, and then the feedback lever is this, which is provides the feedback to the mechanical hydraulic actuator. So it's complete hydraulic mechanical hydraulic structure unit uh, developed in the aircraft system is here, which you need to understand, like how it works, how it inputs the signal, how it gets the feedback, how it to the hydraulic valve control system through control surface. So next part is basically I have just written the complete electro-hydrostatic actuator. Okay, so in the hydrostatic actuators, basically it uses the electro motor with the hydraulic pump, and then it checks the valve and the actuator system with the accumulator and the relief valves as well. And next one is accumulator pump displacement control system with the actuator and the electric motors. And next one is basically uh, this basically the complete structure provide us the different conditions of flight control system to provides its for example, we called it first of all it's fixed displacement pump system. Okay, and next one is basically fixed rotational frequency electric motor and variable frequency variable displacement pump with the variable electric motor uh, pump system basically. Okay, so next I have just placed the digital hydraulic systems with the control system. This is a typical hydraulic solutions used previously, but in our case we have used a this is basically picture view of the typical on-off valve and how solenoid valve work through electrical connector. Like we have in the electrical, it uses a 24-volt magnetic contactor, which on off the solenoid valve through magnetic contactor. Okay, so I have written this complete structure with digital hydraulic actuators and yes, variable speed control digital hydraulic actuators as well as the digital electrostatic actuator thermohydraulics basically, like how we can control the temperature and heat as well. Okay, see, and this is basically dynamic model diagram for the hydraulic circuit, and these are the equations used in the calculation of different parameters of heat transfer system with pressure flow with different flow rates, and it also contains the ambient temperature, how we can reference ambient temperature with the different steady state temperature. The methodology is presents the complete structure, like how we can use SHA and DEHA model in the MATLAB Simulink, and the conditions of analysis, servo hydraulic actuator, as well as the see, these are the complete main parameters used in SHA model with the in Hobson in displayed in table 2. Basically, these are the models used in our cases. So this is basically SHA Hobson model, the diagram. Okay, and the next part is the table which provides the DEHA parameters. Basically, in this paper we have compared the two different models like SHA and DEHA. So we have just added the complete SHA and DEHA parameters with its complete structure diagram as well. Okay, so that's why I have just added the different parts of SHA and DEHA models with the numerical simulations. Like the numerical simulation, we will also compare these two models as well. See, DEHA simulation data, and this is SHA simulation data. Okay, thermal analysis of SHA thermal model. This is the SHA thermal model, and next one is these are the metrics used in different power, temperature, voltage, and speed as well. And then we will adjust the pressure data as well, and such a flow data for thermal modes on branches as well. Okay, so these are the complete DEHA model also presents here, and the Simulink model also developed in the complete structure as well. So node temperature for SHA and the DEHA results are presented here, like these are the node temperatures for DEHA, and next one is the conclusions and everything added in this case. Okay, let me just show you, these are the MATLAB files. You can just check it and run the MATLAB files accordingly, and you will get the output results according to the presented in the paper. Okay, thank you.
Hi, this is the article. I already added the video for the explanation of this article for the thermal behavior of hydraulic system, which is this one. Yes, SHA and DEHA. I only need to show you the MATLAB project files, the demo of MATLAB project files. This is the MATLAB files. You need to run this section for the base of all the files are available in, for example, DEHA final. You just need to run this model. So when you will run the model, you will get the output results like I have mentioned in the report. Let me just also let it just run it, and then I will show you the proper output results. See, these are the node temperature in DEHA system. Okay. So this is basically this one output results like this one, which is this is SHA and this is the DEHA. Okay, so it is just a color difference. Let me also share with you these results. It will having a multiple results, but you will get the same results, exactly what I have developed. And DEHA heat exchanger with the quality to update. See, this is the DEHA node temperature for heat exchanger, for thermal load, for node voltage stability. And this one is also, sorry, this one DEHA update. You need to run this DEHA update and you will get the exactly same like the results I have mentioned in the, sorry, this one, I think, test.DEHA. Yes, this one. Yes, this one. Okay. 20 degree, 20, 80, 80, 20, 20. So it is just like an update of everything. So you will get you just need to run the model and you will get the results of SHA, DHA. And let me just also run SHA model, which is this one. Okay, this is a node voltage stability and SHA update. For example, here you just need to run the SHA, oh sorry, this one, SHA with the verified version and the working of, and SHA update as well, and the DHA test.m as well. Okay, so you basically need to run this model for the complete structure of the report, and you will get the output results like this is a node temperature accordingly. Okay, so basically I have mentioned all the node temperature for DHA and SHA for the results as well. Basically we just need to change the nodes accordingly in this form. For example, this is a 10 by 15 node. We need to change here 8 by 10 or 10 by 15 or 12 by 15 is that way. Okay, so I think this is okay now.